Everybody hear me? Hello?
Afternoon.
Hi, good afternoon. Sorry about the technical problems.
That's okay.
Yeah, it's strange. So we'll move forward really quickly. Let's get off. So welcome to the offsite modular prefabrication discussion. If during the presentation you have any questions for the speakers, please write them in the chat box. I'll monitor these, and at the end of the session, if we have time, hopefully we'll be able to ask the speakers to answer some of the questions. I'd like to introduce Andrea Galindo from ITW Construction Products. They're our sponsor for this discussion, and Andrea, I'd like to take a few minutes to tell us about ITW and introduce both of our speakers, Rory Bergin and Julian Bowan. Andrea?
Absolutely. Good afternoon, everyone, to our attendees and panelists today. I'm going to quickly share my screen here. We have a quick slide. So let me know when you can see my screen.
Yeah, we can see it, Andrea.
I can see the screen.
Great. So you can see my presentation screen.
Yes.
Fantastic. So thank you again for everyone attending, and to our panelists to date. ITW roots are on innovation, and we were founded back in 1912. ITW is a Fortune 200 company with over 18,000 global patents and applications worldwide. Our goal is to strive to strengthen our position as the preferred manufacturer of choice for designers, architects, and engineers who are looking and seeking best-in-class anchor solution for concrete, metal, and wood applications by itself. So we are an innovation company focused, driving ongoing value in the industry by creating simplified, reliable, and top performance experiences across the construction cycle by itself. So these are some of the brands that you might recognize, but ITW Construction Products has a wide selection of anchoring fastening solutions, including Buildex for tapcons and techs, GRK fasteners for wood-to-wood connections and structural wood connections, Ramset, Redhead for mechanical and adhesive anchors, and pass load. So on the InsulFast, and this is probably one of the key player in today's exhibition when we're looking at thermal performance and LEED certification on buildings, we have a one-step insulation fastening system that secures rigid and semi-rigid insulation directly into concrete, masonry, and steel studs. So the InsulFast plastic fastener connects to virtually no thermal bridging, and we can ensure up to 99.42% of thermal efficiency for building envelope insulation, anchoring solutions, as well as P1, parking one, garage envelope solutions. On the red headline, we have the adhesives for anchoring into threaded rod and reinforcing bars to concrete elements. And we have two products because we want to simplify. So we have A7 and C6 Plus. It's an all-in-one adhesive solution with all the code approvals, and it can be installed in any weather installation conditions. And last but not least, it's our new baby. It's TrueSpec, ITW's new anchor design software, which features real-time 3D animations, and it's user-friendly navigation with guided support for designers who are looking to design post-install concrete connections in accordance to CSA. Oops, sorry, I'm missing a screen there. So we offer a wide variety of product support, including online webinars to go into detail for our products. We do on-site pool tests. We have technical reports. We have a new website that I encourage everyone to visit. And for today, also come and join our booth. And we look forward to meeting you and discussing with you later. Okay. So that being said, I wanted to, how do I stop sharing? There we go. Hello. So that being said, I wanted to introduce our today's speakers. We have Rory Bergin. It's a partner at HTA Design. He represents ATH on working groups for the Construction Leadership Council on on-site construction, off-site construction. He has led the practices involvement in off-site research and development of present HTA's work widely on prefabrication. Originally trained as an architect, Roy has worked at HTA since 1993 and has become a partner in 2015. Our second speaker is Julian Bowan. He's an innovative architectural design manufacturer leader with an intuitive grasp of modularity structures and the design process, materials, building systems, and the critical path. He has over 35 years creating and managing multidisciplinary design and precision manufacturing teams and creating off-site manufacturing facilities that successfully deliver high-profile projects around the world. That being said, I welcome our speakers and I hope you enjoy this session.
Thank you, Rory. Let's begin, please.
Sure.
Did everyone mute their?
Okay, can you see my screen, Bob?
Yes, we can. Yes.
Okay, so do you want me to finish at the hour? Half an hour from now.
Go through and then we'll get to Julian.
Yeah.
Thank you.
Okay, Rudy. Okay, Rudy. Thanks. You're welcome. Thanks, man.
Please mute.
Shamana, your microphone is still on. So welcome everybody, and thanks to the team for inviting me to speak today. I'm speaking from the darkness here in London, UK, at the end of the working day. So I know most of you guys will be sort of mid-afternoon. So I'm going to take you through some of our work in offsite construction, which has happened really over the last decade or so. And we have, well, we like to think we have a pretty leading role in the offsite sector here in the UK, and in a few other markets too, where we're increasingly being involved in overseas construction. A lot of this is what we call a DFMA approach, designing for manufacture and assembly. And this diagram comes from the Royal Institute of British Architects. They have an overlay to the RIBA Plan of Work, which is a document that I recommend to you. It gives a good introduction to manufacturing and how it feeds into the design process. And the Plan of Work is a tool that we all use here in the UK and is referred to by a number of other international standards bodies and so on. In terms of our workload over the years, it's grown quite a lot in terms of off-site construction. So we're now a 250 odd person company. We're primarily architecture led, but we have other specialisms in the practice, things like planning and the legal side of approvals. And I run a team that deals with things like research projects into DFMA, offsite construction, and sustainability analysis, wind effects, microclimate, daylight, energy performance, and so on. This sort of expertise recently led us producing a couple of books which are relevant, I think, to the conversation. So the Modular Housing Handbook, which is actually both of these are published by the RIBA Press this year. So the Modular Housing Handbook, which I wrote with one of my colleagues, and Radical Housing, which is also written by one of my colleagues, which really deals with co-housing and other housing forms. So why do we get involved in all of this? Well, a lot of it comes in terms of a pull or a push from our clients. They see all of these issues being increasingly important to them. many of them in particular are interested in the predictability of moving construction into factories. So the traditional construction market here in the UK is not famous for delivering on time or on budget. And in the recent economic upheavals, all of that has been made more difficult and more challenging. So moving things into factories is not necessarily seen as a way to build cheaper, but it's certainly a way to build that's more predictable. So clients like hotel developers, student accommodation developers, private rental developers are all very interested in that predictability and deliverability issue. So they're interested in quicker construction which gives them a quicker return on investment. Also, a lot of our clients, we're building to higher density. Often we're demolishing existing buildings and building to higher density. So there's a lot of existing neighbors around projects and disruption to them. The length of the construction program and so on all has a knock-on effect. In terms of issues to think about, we recommend that clients talk to manufacturers early on to find the appropriate manufacturer for the project. Not all factories have available capacity, for example. The design team needs to understand the discipline of manufacturing and designing for manufacturing, and the client themselves need to make their decisions on time, because there's no point in having a super quick construction process if the client can't actually make decisions in time to support all of that. So in our projects, we've seen up to a 50% improvement on construction programs. So projects that would take, say, 2 years to build on site, we're managing to see delivered within 12 months. So all of that sort of feeds back into the design program and the financial basis for the project. It helps to reduce borrowing costs. It helps to free up staff earlier. And it's good for us as in our business for the same reason. So, you know, here is the time profile and the effort profile of two projects which are of a similar scale. The gray one is an offsite project and the white one is a traditionally delivered project. And you can see that our workload comes to an end when we hand over at the beginning of the construction phase. And then that's the construction phase finishes here quite quickly. Whereas the traditional project, we hand over the project to the contractor, and then a lot of more design, sometimes a lot of redesign happens during this project, this part of the project, often in an attempt to save the contractor some money, but it ends up taking up a lot of time. And you can see the traditional contract took roughly twice as long as the offsite contract. So for a client who is I say a build to rent investor, if they have a choice of a project which is going to take 4 years of construction before they can get rental income, compared to a project where they can get rental income after 2 years, then not only can they start getting that rental income 2 years earlier, but they can get on and do a second project in the same period. So we see the sort of speed of offsite construction as being something that really works in a serial way. So one project after the next, and not really something to consider as just as a single one-off project. There are lots of economic and industry barriers to the use of offsite construction. There are problems with approval processes. There are problems with insurers. There are problems where manufacturers have specific systems which are not interoperable with other manufacturers. There's a lack of skills in the sector, you know. But all of these things are being worked on variously, both by government, by the insurance industry, by the skills sector, which are developing training programs and so on. So all of these barriers are being chipped away at and broken down over the passage of time. Factory capacity is an issue. We have a limited number of factories here in the UK. But what is happening, and what has happened over the last 3 or 4 years, is we've seen substantial investment into those factories. So we have a number of companies either setting up new factories, or we've seen a number of investment, substantial investments in the hundreds of millions of pounds from investment funds or from asset management organizations or buyouts, where sometimes foreign investors have bought existing UK manufacturers that were at a small scale and are working to scale them up, because the demand at the moment outstrips supply substantially. We also work with clients really in planning for demand. So trying to drive demand by working at the master planning level and helping them to identify a sort of a cascading or nesting level of standardization. So with things like kitchens, bathrooms, utility cupboards, balcony types, into standardized apartment types, which in turn go to make up variable buildings, which then fit into variable blocks, which then fit into large scale master plans. So all of this is trying to develop design-led typologies which are available for manufacturers then to bid into and to construct. So thinking about designing for manufacture at the beginning of the project, and not trying to convert the project after it's been designed and after it has all the approvals. Some of the manufacturers are scaling up by involving other manufacturers in a similar way to the car industry has operated, where some of our manufacturing clients build a cage and then buy in subcomponents like utility stores or bathrooms, and then insert those as pods into a cage and then finish off the volumetric module and send it to the construction site. We've also done some work on digital tools, where we worked with a UK government research grant to develop a tool which enabled people to make choices. So this is a sort of a house purchasing system, where, as you can see on the page, people can make different choices, choose a different spec for the housing product, which can then be fed more directly to the factory. So it's about building a bridge, I guess, between the variability of the factory or the customization potential of the factory and the market. You know, what are people looking for? And one client in the UK is using this tool to offer something like 1 million customization options on a series of house types. The feedback is that very few of the customization options are being used, but the information about which ones are being used is really useful and important. So the things that people really care about when they're offered those choices. In terms of systems, not all systems are equal. So here in the UK, we traditionally build a lot with steel, as well as building a lot with reinforced concrete. So the building typology, the building scale, all of that has an impact on the construction solution, as well as fire regulations. We had the Grenfell fire a couple of years ago, which has had a huge impact on the insurance market, and is changing regulations in terms of the fire performance of buildings. So a lot of changes have come into the design processes. Many of them for the good. You know, many of them are introducing better processes, safer designs, and safer construction. A lot of our work is on the right-hand side of this scale. So on the left-hand side are the sort of factory-made components that go into buildings. But moving all the way to the right-hand side, volumetric construction tends to be about 70 to 80% of the build coming from the factory. So these units come from the factory, finished inside, with most of the furniture, certainly the fixed furniture, installed in the factory. And a typical process for us, that the factory manufacturing starts at the same time as work on site. So there's a period of work on site to clear the site, put in the foundations, basements, and so on. And then to usually erect a slip-formed concrete core, often with a podium. And then by that stage, the modules are completed in the factory, and they start to be delivered and installed. The rate of installation depends on the scale of the project. I think the maximum per crane is 10 or 11 per day. So 10 or 11 room-sized modules, which equates to about 3 to 4 one-bedroom apartments installed in a day. And then when we get to 6 or 7 floors of construction, then mast climbers are used to install the facade. and then the two processes sort of chase each other up the building to completion. So some examples of buildings that we've done. I should say too that in terms of the sustainability benefits, that our research, and we've done a piece of research with a Scottish university that demonstrated that we can save about 40% of embodied carbon in the construction process by going down this fully manufactured route. So that seems to us to be a pretty important signal that we're going in the right direction with this, and we hope to improve on that with further work. And that isn't taking into account, that isn't using cross-laminated timber. So there are some manufacturers in the UK using cross-laminated timber for lower-rise projects. So they will be going much further than a 40% reduction because of all the benefits of the embodied carbon in the timber construction. So some of our buildings that we've completed. So this is a cluster of buildings. All the buildings in the foreground here, this and this were all designed by us and constructed using volumetric modular construction. So you can see there are different facade types, different facade systems, different building heights, different types of architecture. So we don't see it as being a barrier to design quality or a barrier to sort of architectural ingenuity. And in terms of the timing, so that central project here, which is called Apex House, this is a student accommodation building near Wembley Stadium in North London. And we started working on that in April 2015. We got approvals March 2016, started on site November 2016, and handed over the building in August 2017. So at peak, the tower was growing by a floor every 2 days. And this kind of process is one that we've repeated numerous times with this manufacturer in various other sites in the UK. And it's a sort of an illustration of how quick the process can be. And this, because this was a student building, the date that it was required was a fairly important date. So you can't have a situation where you don't finish the building and you've got 400 students waiting to be housed. They've got to go somewhere. So that's a kind of illustration of a kind of a perfect marriage between the manufacturing system, design and manufacturing, and an economic need and an economic benefit. In total these days, we've built actually since we're probably up to 7,000 units by now with multiple modular manufacturers, including the tallest modular building in the world, which I'll show you shortly. So we feel we're pretty well qualified to talk on the subject. And this is not all the projects that we've constructed using this technology, but it's an illustration of most of them to show the sort of spread of typologies, heights, and sizes that we have delivered. And this, people say to me, well, everything must be the same, mustn't it, when it comes out of the factory? This is a diagram of most of the module shapes and types that we've used to complete those buildings. So in some cases, these shapes would go up 10, 15, 20 stories. So they'd be identical when stacked on top of each other. The long, thin ones are corridor modules. So sometimes, if it's appropriate, we build the corridor units as modules. Often they're not. Often they're incorporated into the end of a module. And then the triangular ones and the unusual shaped ones are just reflective of the fact that sites don't come as squares, and that we have to design, triangular buildings or buildings that bend around corners or whatever to deal with the needs of the particular sites. So I'm going to talk a little bit about this project here, which is called 101 George Street, which is a build-to-rent project funded and owned by Greystar, an American multifamily investor. So we took on an existing planning permission for a project and then redesigned the building to suit the volumetric modular system. It's beside a major transport junction in South London, in a place called Croydon. You can see here early stage in the construction process where two of the two cores are up. So there were 44 stories and 36-story buildings. You can see the sort of complexity of the site with a deep basement and a lot of services, diversions needed. And then an early stage of the construction process where you can see the core here with sort of fixing positions cast in for the modules and one of the finished modules being installed on site. A couple of points to note. One is that the modules are protected from the weather and from fire, from leaving the factory. So when they arrive, they've got windows in, they're sealed units, they're waterproof on top, and they have cast in fixing points. So when these modules are lifted, they're lifted using this framing system to make sure that no uneven stresses are placed on the module, because these are usually 15 tons or a little bit more. So it's pretty important that they're not bent or twisted in any way. Also because the bathrooms inside are tiled, there are mirrors on the wall. So if you bend and flex all of that, then you'll do a lot of damage to the finishes. And then the cladding, which is in this case is a glazed terracotta system from Austria, and that was brought in and installed as large scale elements on the facade, attached to a support system, which in turn is attached to the modules. So the sort of construction process that you can see here using two mast climbers. So you can see one mast climber is here installing the facades, and the one above is doing the sealing between modules and then installing the bracketry that goes to support the cladding system. So at any one time, there were sort of two pairs of mast climbers operating on all 8 facades. So the ability to have lots of parallel working going on the same construction site. So you see here a more advanced stage in the construction process. And there, the building nearly finished. The building has subsequently been finished and is currently sort of undergoing final sign-offs before occupation. And in a similar project at a much smaller scale, also in London, this one beside a busy underground station. So there are lots of restrictions that are involved in terms of deliveries and construction. So again, this one was built using the same approach and built from a single lane on the highway. So closing up a single lane of the highway, using that to deliver the modules, and then craning the modules into place on the building, enabled the project to be delivered. This one was built in 9 months from start to finish. It's about 250 student bedrooms. Another project which is underway at the moment, this building in the foreground has been completed and occupied, although this is a CGI. The rest of it will be built out over a period of time. This is also a Greystar project, and this is a multifamily rental project. We designed this as not necessarily as a volumetric modular project, but Greystar chose to go that route because of the certainty of delivery for them as a rental operator. And we understand that they're now looking at using the same approach on their projects in the US. Although I'm not aware that any of their projects in the US have actually progressed to this stage. We're currently working on the second part of this block, which will be delivered shortly. So that's the completed building there, which is now rented and occupied. And then historically, this was the first building that we did about 8 or 9 years ago. So this has been occupied. This is a hotel in the foreground, as well as affordable apartments. And the blue building is a private rental building. So this was the first project we did. And again, it demonstrates the variety of architecture, the sort of shapes and sizes that you can have from such a construction system, not really presenting us with any barriers in terms of design or design quality. And then a project that we took over from another firm. This had been designed as a private rental building, but not designed as a volumetric modular building. So we took this on for the construction stage and designed it to be constructed using volumetric modular. And it's now built, finished, opened and occupied. And you can see one of the modules from a different manufacturer there being installed and one in the factory. And actually, one of the interesting things about this was that they built an entire apartment in the factory, including all the finishes for the client to come and verify before starting construction before starting production, if you like. So it's a fantastic route to prototyping and getting the quality right. And then they took the apartment apart, put it onto some trucks, drove it around the streets for a while, brought it back to the factory, reassembled it to check that the finishes, etc., had withstood or were still in good quality after the transportation process. And then I'm just going to flick through some other buildings we've completed. This one is under progress. And then some designs for lower-rise housing that we've worked on and are continuing to work on with a number of clients, which are either underway or are in the sort of early design process. So a number of low-rise housing, this one is on site at the moment, so a number of low-rise housing projects which will be delivered using similar methodology. So I think that's enough for me. So Bob, I don't know if you want to take questions at this point, or do you want me to wait until the end?
We'll let Julian take over, and then we've got a couple questions at the end.
Okay.
Thank you, Julian.
Can folks hear me okay?
Yes, we can. It's great.
And are you seeing my screen?
Yes, yes.
Good. Totally fabricated. That's my portfolio. So, well, thank you very much. That was extremely interesting, Rory. Thank you. I admire the work of your group tremendously. I'm a huge fan. As I think some of you may know, I've been making attempts to implement things on the same scale here in North America through my various inventions and companies that I've founded and run. But today, by way of contrast, I thought I would present some things kind of from the opposite end of the spectrum. In that fully volumetric modular construction is all the rage, and I'm a huge fan. As I said, this is not meant to be an insult to it. The challenge, of course, is that implementation requires a huge commitment on the part of everybody concerned. And so there's a lot of people that are not in a position to make that kind of a leap with their companies in various portions of the construction industry. So I'm going to highlight here some things that your organization can do now to benefit from the efficiencies that offsite methodologies deliver. So here's a project going back a few years. This is a very complex architectural ceiling, acoustic treatment for a performance space. And what you can see here is, you have a very large number of unique components that are only slightly
Julian,
different.
sorry, we
Yes.
can't see your screen.
Your screen.
Oh, you
Julian.
can't? Oh.
Nope.
Let me try that again.
Presentation.
How about that?
It's moving.
It's moving. There we go.
Got it.
Okay, I'll just back up then. But you did hear the introduction.
We did,
Yeah.
yes.
Okay. Yeah, it appeared to go out there for a second. So, so there you go. So now we're on to the first slide. So the challenge is you have a very large number of unique components, which are, would be chaos from a production viewpoint. And so the standard procedure is somewhere in the chain where people are machining the components from a CNC program. This is all this work is done in parametric parasolid modeling platforms. Somebody might put a bar-coded sticker on it, or a laser might add some etching to it or something like that. But in order to actually code the part right at the point that it's cut out, we developed this system of markings, which are basically notches of various lengths and depths that are put into the part by the tool that actually cuts it. So no secondary process has to be employed to identify these components. And as a result, they were very easy to identify and install on the site. So just simply piece marking is a way of adding tremendous value to an offsite produced part, so that people in the field aren't handling wet pieces of paper that are flying around, and tags that are being yanked off and so on. And you don't have that secondary process you know, to add, as I said, barcode tags or whatever to the parts. So this, you know, there's much talk about model coordinated work, single source of truth, working methods, and so on. These are all examples of Industry 4.20 implementation in construction, but they may often not look like that. And so I'll take you through a project here that, you know, is very definitely uses all the techniques that are common to the automotive industry and the aerospace industry and so on in a one-off high-end architectural application. So we start frequently with a scan of the entire building using LIDAR, and then model our project into that scan. So we eliminate entirely the whole idea of, you know, total station surveys and so on, and go to actually, you know, a point cloud based model. So now you can model the components. This is a view up into the underside of a stair structure. You can model with a tremendous degree of certainty. And then in the same model space, exactly, with everything literally nested together, you model all of your tooling, mold making, structural steel, mold supports, you know, you name it, are all modeled in the same model space in perfect coordination. And even the fixturing to produce the components is modeled in the same environment. And we can make some very, very complicated shapes. And again, know very dependably, you know, precisely the geometry of these objects. And so you see here, this stair fixture model coordinated, fixture fabricated, installed at the site. And there was literally no cutting, burning, you know, any kind of adjustment taking place on site. The parts butted up against each other perfectly and installed with, you know, basically zero adjustment. And simultaneously, and this echoes very much Rory's working methodology with the full volumetric modular buildings, simultaneously with the steel going in the site, we're working on the cladding package in a completely different facility. So making a large model coordinated mold, making the mold support. So here's that's a rendering of the computer model of the mold with its support structure. And there's the finished mold with its support structure. And here is the part that came out of that. This is the mold itself. And then these are the parts that came out of the molds. And you can see they're all prepared in the factory to be seamed together. And they, for the first time ever, are making contact with the steel structure and are quite perfect, joined together. And there's the finished product. And kind of the miracle of this type of process is that no component in this project was ever in the same room at the same time during the process of fabrication. And in fact, the machined wood treads came from Brazil, already machined, lacquered and finished. The glass fiber reinforced polyester or plastic shell was made in my shop in Toronto. The steel came from the Walters Group in Hamilton. The glass came from a glass bender in the US, and literally it all fit perfectly at the site. And I really do mean that. I mean, there was a virtually zero chip installation here. So you know, here's a kind of a rest and repeat. Here is a 3D laser scan of a very complex, you know, 12-sided ramps, etc. space, quite imperfect, cast reinforced concrete. So that really the virtue of the 3D scan is quite clear in this case. So then we model all of the systems in roughly and sort them out. Then we kick out some renderings in order that the architect can really truly understand what they're going to get, how we've interpreted their work. We then refine all of the components until they really are, you know, fully manufacturing level cut files. Divide the work into the scopes that will be handed to the various trades, and then fabricate molds, do some prototyping just to make sure that everything's working. And in this case, the real secret here is an interface frame between the very coarse and inaccurate base building and our very, very accurate interior finishing package. And there's the final result. So this entire interior is completely shop fabricated offsite, and not a single component has been adjusted in any way at site. And it includes literally everything that you see in this image, except for the carpet tiles, the electronics in the rack and the desks in the background there. Otherwise, this entire interior is completely offsite fabricated in every detail, and it's, as you can see, a very complex interior. Of course, there's an enormous number of details to be managed in a project like this, and so something I've been advocating for quite a while and have implemented now several times is the situation room working methods. So here you have multidisciplinary teams. You might have a structural designer, a mold designer, the MEP people and so on, all working literally side by side in real time, which is a dream in time of COVID, by the way. But the technology for sharing has improved quite a bit, though there really is nothing to equal this sort of environment. And you can see, by the way, my office up above there, overlooking this space, where we can actually, we have an openable window and we can yell orders and comments back and forth, and maintain a very high level of, integrated working. This is the kind of engine room of a facility like that. These are component specifiers and component modelers. So these are people, modeling every plumbing fitting, every wiring harness, every component, and feeding them to the modeling group in the main space. And this actually shows a cross section through this facility and how the workflow is coordinated in order to produce this type of highly accurate, very complete modeling that is the underpinning of this type of offsite fabrication. So speaking of pods, we're proud to have done one of the, we claim to this day that this is the top pod project done since the Hong Kong and Shanghai Banking Corporation and building in Hong Kong in the early 80s. This is another Norman Foster building, by the way, the Bow in Calgary. And so here we did all of the washrooms as modules. They were modeled in context with the base building steel. We can then render those to a very high degree of realism. In this case, the interior renderings are useful, highly realistic, but in fact, so are the exterior renderings. We found these very, very helpful in terms of explaining to the staff on the shop floor what to do, exactly how things went together. When you put the galvanizing texture on the galvanizing and the drywall color on the back of the drywall and everything else, it removes a lot of the questions from people's minds about how the work will proceed. You can see here a detail of the plumbing showing literally every component is represented by a cut file level rendering of that component. And by the way, all the pipes are dimensioned to their precise length, even including the portion of it that fits inside the collars and so on. So this further allows us to do things like manufacturing pipe strings in the way that a large scale EPC contractor would, in accordance with the model geometry. And of course, panels and ceilings and so on, all made offsite, and then assembled at the last minute and very quickly to create the finished modules. So this shows, various stages of assembly of these things, which were, by the way, this is sort of $700 a square foot stuff, whereas, the typical modular building might be $250 or $300 a square foot. Here's your, the happy plumbers working in very, very comfortable conditions. They're not, on the 40th floor of a building in Calgary in January, in minus 30-degree weather, and using a porta potty. This is a far better situation. And in fact, our plumbing costs per module were, and this is really no exaggeration, they were 1/8 of the figure that was budgeted for the same work on site. So people could complete all of the plumbing on one of these modules in a couple of days, whereas the same work was anticipated to take a month on site with a larger crew. And by the way, the fellow in the inset to the right is testing the sprinkler system in the plant. So there's a view of the interior of this completed. This photograph is taken in the factory in Ontario of a module that will end up in Calgary. Rory mentioned this idea of transportation. Here we have to have an extremely rigid, diagonally and torsionally rigid chassis because of course the interior is entirely lined in back painted glass and granite. and any movement whatsoever would cause the edges of the glass to come into conflict and shatter. So, so stiffness in the frame is paramount here. And here's your shipping with the classic boat wrap. In fact, I spoke with somebody at the factory yesterday. He was asking me, no, it was this morning, in fact, he was asking me about selling the prototype that we built, which has been sitting in a field now for 8 years in this boat wrap. And I said, have you been in it lately? He said, I went in it yesterday and it's perfect. So it's interesting, this boat wrap outdoors in Canada in sunlight has actually lasted 8 years, and there's been no effects of humidity or freezing or anything. All the glass is still on all the walls and everything, really quite remarkable. So in this case, unlike the volumetric work where the modules are actually forming the building, in this case, they're sliding into an existing building. So we create this platform that is, notionally gravimetrically neutral. It has that tail end hardware so we can level it. And here you see it docked into, in this case, it would be the 33rd floor. And the air bearings connected. Here you see the workers maneuvering the module on the air bearings, which are supplied by an airline. You can see the yellow larger line over at the left. This, to be honest, is very noisy and very dusty work. But here's the tail of the tape at the end. There is the computer model of the module in the computer model of the base building steel, and there's the finished product. Computer model of the module in the computer model of the base building steel. And you'll see that there's absolutely zero variation between the two. And interestingly, you can even see from the LIDAR survey of this particular floor, bumps in the floor that have shown up on the actual site. It's pretty funny. This is the last slide in this group. I think I'm going to try to keep this short because we're running out of time. There are more, but I put in a halt at this point, an accessory halt. This just shows you how, some of the details we developed for a very nice project. We have a tray forming the bottom of a shower stall in a hospital, infection control environment, where the tray has a perfect detail that leaves the tile perfectly flush, but has a nice return up the back so that there's no chance of water leakage there. Underneath where the hand holds, for disabled access, have a solid machined stainless steel slug that carries the load to the blocking, and a cast silicone custom gasket between it and the glass. So instead of having an ugly, silicone detail or whatever around the base of the handle, you have this very, very super clean detail that seals quite perfectly. And on the right there, it just shows you where the access panel goes as we plan the connections to all of the systems within a typical module. This really is the key story here. In the Bow project, this was very, very important because there was very limited man lift capability or person lift capability. This is the modular rationale, Ne plus ultra, which is that a single crane lifting one of these AAA quality modules delivers the equivalent of 250 man days. This slide is a few years out of date. It should be person days of labor and 50 carts worth of materials to a working floor. And this made a very significant difference on this particular project where the lift capacity was very limited, and there were serious traffic jams on the way up in the morning and on the way down at the end of the day. So there you go. Just keep that short and sweet, and we can move. Hopefully, Bob, this means there's still time for questions. I think your mic is muted.
Rory's been kind enough to answer questions in chat. We did have one gentleman, Julian, reach out, and he wanted to know how to get a hold of you. So there's your contact information. Does anybody have any questions? You can unmute yourself and ask questions. We have a few minutes before our time is up and the next seminar starts. I'd really like to thank Rory and Julian for the presentation. It's fascinating. I see this as being the way of the future. I think we're going to see more offsite modular and prefabricated construction in the near future. I also want to thank ITW for being a sponsor of this presentation. And please reach out to Julian and Rory if you have any further questions. This time, I guess we have to get everybody to move to the next session. Thank you, everyone.
Thank you.
Thank you.
Thank you, Rory. Really appreciate you taking time, and I'm sorry about the technical problems.
No problem.
Get there.
Thank you.
Thank you, everybody, for tuning into this presentation.
Yep.
Appreciate it.
Have a good day.
Yeah, thank you so much.
Thanks, Rory, for taking the time from England.
My pleasure.
Take care.
Okay, bye-bye.
Talk soon, Julian.
Bye-bye.